Okay. All right, so chapter 8 is about the hardware. We're going to talk about switches, routers. We're going to talk about the NIC card. So things that we've talked about before, but now probably just looking at it in a bit more detail. All right. Let me pull this up here. All right, so that's your page 373 in the book, 373. So you want to have your book open, as usual. All right, so let's see let's go right in here. And we talked about this in chapter 7. That is the data link layer in the OSI model. The data link layer is that the last layer? That's the layer before the last layer. The last layer is the physical layer. So the data link layer is your number 6, well, number 2 in this case, because it's looking at it in the reverse. So layer 2. But when you count from the application, then you go down to number 6. So, but let's say layer 2, all right? So the data link layer is where you will get your MAC address, all right? That's where you get your MAC address. And we refer to data at that layer as a frame. So when your data now has MAC addresses and stuff, it's now a frame, right? When it gets, just before that frame, on the network layer, when it gets the IP addresses, it is a packet. So at this point, it's a frame, all right? Now, we kind of mentioned this before, this concept, this, I guess, description, flooding the frame. Mentioned it a while back, so let me see if you guys actually remember what we're talking about here. So let me pull up a picture here of a switch, network switch. All right, so here is let's get a good picture here. Let's get one that has a couple of, all right, let's just use this one here. Oh, it's not too big. All right, let's use this one. Oh, maybe this one, yeah. All right. So right here, it talks about what we call flooding the frame. And flooding the frame is, Jojo, let me go back to you, let's see if you guys remember this part here. So flooding the frame, when we talk about hubs, right, if you remember from way back when we talk about hubs, every computer or every cable that's attached to a hub, right, when the hub receives the message, say the message is for this computer with the white cable. Well, the hub doesn't know any better, right? So it's going to send the message to all the computers that are connected. Does that ring a bell to you, Jojo?
Yeah, it does.
Say it again?
Yeah, I remember that.
Okay. So the hub, that's what the hub does, because the hub is not intelligent. It's not a smart device, right? It doesn't read any data. It does a lot of bandwidth sharing, right? So when the information comes to the hub, it just sends that information or message or data to every single computer that's connected to the hub, right? We use the analogy of mail. When if mail comes to your street, and your mail is duplicated to every address on your street. So your mail is given to to your neighbors. Their mail is given to you. Everyone gets everyone's mail. Kind of like when you get junk mail in your email spam folder. All right. So that's the idea of flooding the frame. It's a huge a huge description or a couple of terms. But flooding the frame there says that it guarantees that a frame with an unknown destination address will reach all network connections. Right? When the device, that is, when you don't, the hub obviously has no idea, who owns this message, which computer. It just sends it to every connected computer, right? Now, the switch is a much smarter device, but the first time you connect the switch, so if this switch, this is a picture of a switch, the first time you connect the switch or you connect a cable into a switch, right? The switch doesn't have the information. The switch has not updated its switching table, like its database, and so the switch goes into that flooding the frame mode, right? So let's say again back to this computer with the white cable. Let's say you take this cable out for the whole day and you plug it in, the next day. Right? Now, the switch needs a moment to update its information for this cable. Brandon, let me go to you. Are you there?
Yeah, I'm here.
Okay, so when we say flooding the frame, right? So you take out this cable and you put it in the next day. Now while it's taken out, or let's say the very second that you put it back in, somebody tries to send an email or whatever to that computer. Well, in that instant or those few moments, right, the switch has no record of this computer. And so when the message comes through to this cable, okay, first of all, Brandon, what information is the switch looking for? When we say it reads the data, what's it looking for to know what computer is connected? Do you remember?
Is it the physical or the MAC address?
Well, same thing.
Oh, okay.
It's called physical, it's called MAC address. So, yep, you're absolutely right. So in that instant, right, Brandon, the switch is looking at this database or at its switching table and like, where is the MAC, who owns this MAC address? I don't seem to have this in my database. So, well, I'm just going to send the data to all the cables, and any one of you guys get back to me if it's your MAC address. That's literally what the switch does. It's called flooding the frame, right? So it basically broadcasts the message to all the cables, right? And now this white cable says, "Oh, that's me. That's my MAC address. So can you update your information?" Which is exactly what happens, right? So the whole idea is flooding the frame. So you can imagine, Brandon, let's say, first of all, it's not a good idea, right, to just, for the fun of it, just pull out cables and stick cables back in, just constantly doing that. There's no reason to do that. Just pull out the cable and put it back in, because it's going to cause a disruption. You can imagine it's going to cause a disruption because every time messages go, this is just a few computers here on this switch. We looked at some pictures before where you have lots and lots and lots of, computers that are connected, right? A whole lot of computers connected to switches. Here is a picture of, a lot of computers, and, you're going to see massive in any solid network. You're going to see a lot of computers. Right, here's another good picture. Right, you're going to see a lot of computers all connected to your switches. So there's really no reason to pull out, cables from the switch, except you absolutely have to. But there's that flood in the frame idea, which the frame does. So basically, you're saying that the frame goes back into a hub mode, where it can't read the data because it doesn't recognize that information, and it floods the frame. The computer that has the MAC address responds, and now the switch is able to update its switching table, and business goes on as usual. Make sense, Brandon? A little bit? Okay. So that's flooding the frame, and we see that information right there. Let's see, what does it mention it first? Yeah, it mentions it on page 374 at the very bottom of the page. Actually, 374, and then it kind of overflows to 375. Excuse me, to 375. Okay, so you're going to see that a few times in assignments or exams. Flooding the frame is a important concept. Okay, let's see what else. All right, here's some, information for you. So I'm going to just share this with you guys. I think the video is more relevant. Let's not worry about the other one. I'm going to put this for you guys in the chat. All right, so you want to bookmark that and, use that when you do your study. Actually, let me go there and see. It gives us some, useful information about, this idea of flooding the frame. Let me see. Yeah. So when you look at it, you get some, some more, I guess, a kind of a video illustration from this guy here. All right. Okay, let's see what else we got here. All right, so remember, just the last thing, like it says here, when the unknown device responds with the traffic, that is, the correct device says, identifies itself, the switch will automatically learn. We've used that word learn, right? The switch learns. Basically, what we might say update, right? Update is switching table and will no longer flood traffic destined to that device. Now he sends it directly to that device, right? All right. Let's go to full duplex, right? Full duplex mode. Brooke, you remember what full duplex is compared to half duplex?
Yeah, so it can both transmit and receive like at the same time compared to only being able to do one at a time, like a half duplex.
Absolutely. Absolutely. And it's right there on page 375, like right below that diagram. Switch ports can operate in full duplex mode on page 375, right? Allowing connected devices that also support full duplex to transmit and receive simultaneously, right? So that's what Brooke just reminded us of. So when it does the simultaneous thing, it says it eliminates the possibility of a collision, right? So it goes back and forth, in that simultaneous direction. Okay, so yeah, that's just pretty simple. Now, there's a little note there on that page. With switches, collisions can occur only if a switch port is connected to a computer running in half duplex mode, or if the switch port is connected to a hub. So you're going to have obviously in a half duplex situation, right? You don't have traffic. All the disadvantages we talked about when it comes to what you might call when you talk to half duplex, right? So you just want to remember that full duplex and half duplex. Full duplex means you can transmit and receive simultaneously, and that's what a switch does, right? Now, even though you can set a switch to a half duplex mode, but it's only when you need to absolutely do that. And this is going to be a tough question I'm going to ask you guys now, but I'm going to ask it anyway. Michael, so where on my computer can I change the half duplex and full duplex thing? Remember?
Oof.
That's why I said it's a hard one. So
yeah, it's a hard one.
Control panel. Maybe I should put in the final exam. How about that?
Yeah, sure. As long as we know now. Yeah.
So
I'd assume you do it from the NIC card, right? From network devices, from properties.
Yep. So you go here, you go here, you go here, and you go here. You see this configure button here? Mm-hmm. Because it's part of your NIC card settings. So you go to configure, and you go to advanced. So you see it's kind of like 4 or 5 steps. I mean, once you get here, right? Once you get here, just remember, don't go down here. Don't go down this way. Just go to this configure button here. Mm-hmm. Oh, I went too fast there. Okay, I need to close that. Go ahead.
I have a little bit of a funny question because obviously, as knowing how to do it is a thing, but when would we ever do that?
Well, that's why I said you probably will never have to do that. Yeah. But well, let me tell you when you have, because I guess with switches, right? Okay, so let's go back here. So switches are smart devices, and if you go into this settings and you go all the way down to, I think it's called speed and duplex right here. Mm-hmm. Now you can see that it's set to auto negotiation. That is, it's set to automatic, basically. It's like when you have auto updates on your computer, it just does its thing by itself when it's ready or something like that, right? You don't need to tweak it. So the switch is able to, should I say, balance the load. If traffic is, if there's a lot of traffic or a lot of congestion, it can kind of slow things down. It can, it's like, having a traffic police on the streets. When there's traffic, they redirect this way or they direct that way. There's a diversion, stuff like that. The switch is able to handle all that, right? But there are times where, well, it's mostly with hubs, right?
Right.
I mean, I did this when I was working professionally, and we had a mixture of switches and hubs, believe it or not, right? Wow. And so sometimes there'll just be this slowdown in the network. And so I'll go in here, right, and I'll change this manually on a computer to half duplex. And so what happens is it decongests the traffic, but then you don't move as fast, but at least your traffic, you can move a little bit. So your computer, your internet works, it's not all broken down. It's not as fast as it was, but at least you can get something done, if you know what I mean.
Right. You can make it work until you fix the problem.
Exactly.
So more or less, this is something to keep in mind if you're working for somebody who doesn't like to buy new equipment.
Well, absolutely. Yeah, especially if the switch, because it depends on the configuration of the switch, right? If the switch is not, is not a very current switch, right? And like you said, they don't have a lot of equipment, they don't have a lot of money, they have very old equipment, maybe, some client of yours, who knows, maybe, whatever it is, the computer, the device is old. You just go in here and then you got to do some manual tweaking. So it's like when you change what you call it now, a street that is, what do you call it? Just a regular street, right? Cars going in both directions. And now you change that street to a one-way street, right? Now, it doesn't mean that all traffic comes to a stop. It just means, well, things are going to go a bit slower. You know what I mean?
Mhm.
So yeah, you go in here. Once you get into your NIC card, you go all the way. You go into Ethernet. You go to properties, and then you hit that button there, and it's going to take you right there to those settings. All right. So
Okay.
that's what that is. So yeah, like just something to keep in mind. I mean, but because the thing is, if you mess around with this without knowing what you're doing, you might really mess up your your whole connection. So
Right. That's a good thing to
somebody who
remember,
is
though. So
more
if you ever work for
experienced,
somebody, you know that like, wait, why is there a hub here? You're like, okay, I know what I need to do.
exactly. Yeah, because there's a tendency for us to think that everyone has the same equipment, everywhere. No, there are places you go to and they have things that are pretty old because it works for them. So you need to know how to adapt in that kind of a setting, right? And in fact, I always recommend if you're going to look for work as a new IT person, look for those kind of places where they really need you there, not just pushing buttons around and it's like anybody can push a button. All right, so that's where that is. All right, let's move on here. And that's what I just showed you, the different modes, that can be set up. All right, and that's what that is. The auto negotiate mode is the. Okay, so you see what it says here, Michael? It says inexpensive switches. No, well, that's a bit misleading. The whole point is the switch sets the mode to the highest performance setting, right? The connected device support. So I don't know why they say inexpensive switches here. This is a bit confusing. But we can cross out the word inexpensive and just say switches run in auto negotiate mode, right?
Mm-hmm.
And the switch sets the mode to the highest performance setting. So, like we said. All right. Okay. Let's see here. So, talking about, it says the switching table holds MAC addresses, obviously, right? We talked about that. In your switching table, we have a picture of the switching table again on page 377. So your switching table is basically what we refer to as your switch database, right? And now, what is in that switching table? The switching table contains the MAC address, the port number, right? So back to this picture here, the switching table, for each of these cables, the switching table has the MAC address and the ports, right? The port that these cables are connected to. So if I zoom in closer here, you can see, there's one, there's one, there's two. So the guys up top here are probably 1, 2, 3. The guys at the bottom are 13, 14, 15, something like that, right? Or maybe the guys up top are 1, the guy at the bottom, whatever. But that's what the numbers are. So those are the port numbers, right? So the white cable here and all these 5 blue cables, they all have their port numbers, each of those ports, and the MAC addresses are stored in the switching table. And it tells us in the book that the MAC, on page 377, Cindy, how many MAC addresses can the switching table support?
8,000.
8,000. So that's a lot. And that's kind of like a standard, maybe more, maybe less, but that's like a standard, I guess, quantity of MAC addresses, 8,000, 8K. All right. So for all the connections that are coming through to that computer, every time there's a connection coming to the switch from a different computer, remember, part of the information coming through to the switch is the sender of that information, right, is also bringing in their MAC address and their port number to this switch here, right? So for every connection to your computer, basically, right? It's like Cindy. Let me go back to you. I don't know if this happens, but let's just imagine. Actually, it may happen. Who knows? Let's say at the post office, right, in your zip code. For every time a letter or a packet or a package or whatever goes to your house, we assume that the post office has a record, right, of that information.
Yeah.
So the idea is, how many such addresses can the post office store for one particular, address? That's kind of like the idea. Every computer or every device trying to reach your own computer coming through the switch is able to store that information. It just makes it easier to process, right? So it knows, okay, boom, the message comes through, the switch looks at the switching table, oh, I know who that is, boom, sends it over to you. It's able to process that many. And we all know that when you look at your computer, especially if you run Wireshark on your computer, I think that was part of the last assignment, you're going to see that your computer is constantly, in conversation with, who knows, so many other devices. Like your computer is constantly active, even when you are not really doing anything. It just seems to constantly be getting some updates or something else, right? So the switch has all that information to make it easier and faster to send information to you or to your device, basically, right? So a lot of stuff happening in the background, guys, a lot. So that's what we mean there when we talk about the switching table holding those many MAC addresses. And it says here that when the switch is first powered on, its table is empty. Obviously, it's empty, right? So it needs a moment to update its switching table when you start connecting all the computers to it, or when it's first powered on. It takes a moment, to get itself together. Just like a human being, you wake up in the morning and like, give me a minute there, let me get myself together. Maybe that's how it works, right? Okay, and that's what it says at the bottom here. If a frame's destination address isn't found in the switching table, then the switch forwards the frame out all ports. And that's what we just described as those terms we use. What's the term again, Abdurrahman? We just talk about the term now. It's like FTF for short. Abdurrahman, are you there? Chris L?
What's up? Wouldn't it be called flooding the frame?
Flooding the frame. I just gave you a short acronym, FTF. It's never called it. I just made that up. FTF doesn't exist, but flooding the frame, yes. So that's what it is. You can't find it. It's going to send it out to every computer, and then it updates its switching table. And that's your, you guys have seen this before. That's your switching table right there with the MAC addresses and the port numbers for all the devices that are connected. Okay, let's move along. Okay, two concepts here. Timestamp. So in the switching table, back in the switching table here, there's also some pieces of information, let me say. Two things: timestamp, aging time. Timestamp, aging time. What is the timestamp? What does timestamp? What does it sound like? So let's say I go into my computer. Let's say I say I'm just going to make a note here. Just say
timestamp. Isn't timestamp like basically using the actual term? Isn't like the time that say you when you save something, you leave a timestamp.
Exactly. It's time when it was made or created or done. So,
Or last
say for
saved.
example here,
What
I'm
time
going to
it
go
was
into
last
this
saved.
file,
Mhm.
right? I'm going to save this file in this junk folder here. So save as, go into my junk folder and just say stuff one, save. All right, where is it at? So you can see right here, right? If I look at the properties, you can see that it was created when, right here, 1:02:42 p.m. today. That's the timestamp. The timestamp is when it was done. All right. So same thing with switches, right? When your information comes through, it says when a switch receives a frame, right, from the device in this table, it updates the entry with a new timestamp. If you look at your phone and look at all the emails that have come through, or actually all the text messages or all the phone calls you've received, you're going to see a timestamp. When did this call come through? When did this text message come through? That is a timestamp. Okay, the timestamp. Now, the other, I guess, piece of information there is what we call the aging time. The aging time is like the expiry date, right? So it says right here that if the timestamp isn't updated within the aging time, the entry expires and is removed from the table. The aging time. Edwin, do we need to explain this further? This aging time, it looks clear to me, but what do you think?
Yeah, that kind of makes sense to me.
All right, so that's your expiry date, right? So think about it as using your microwave. So we can say the timestamp is when you start to microwave your, what do you microwave? Your pizza? Do you microwave pizzas? Or whatever it is you microwave.
I mean, you can microwave pizza, but
actually, when you buy a microwave, right, and you read the instructions, one of the things it says in the instructions, do not dry your shoes in the microwave.
You're kidding.
It might cause a serious. Oh, absolutely. Do not dry your, because you might think that, oh, my sneakers just got wet and I've got to run out to the store. So, just quick. Let me just do it quickly. Well, you're going to see right there. Do not do that in your microwave. Anyway, so let's say you start to microwave your, your pasta, right?
Mhm.
At 12 o'clock. 12 o'clock. That's your timestamp. Okay, I just started it right now. Now, the aging time is, I'm going to microwave that stuff for, 2 minutes. So 2 minutes is the aging time, right? So think about it as expiry. So what it's saying here is the timestamp, right, has to be updated. It has to be regularly updated. That is, basically, it shows us that it's being used, right? It's being used. Something is happening. It's being used. It's like your computer, right? Your computer, whether you realize it or not, your computer also has a timestamp and an aging time. That's just your monitor. Now, how does that work? So you might realize, depending on how you set it up anyway, that maybe if you don't use your computer for a while, maybe 5 minutes, 10 minutes, who knows, it maybe goes blank or it goes into sleep mode. So it depends on how you've configured your device to save you what you call it. Actually, look at your phone, right? Your phone, if you don't use your phone for, a couple of moments, it goes dark, right? So think about it as timestamp. Timestamp is the moment when you switch that phone on and you start using the phone. Aging time is how long does it take before it's going to go dark. If you don't want your phone to go dark, you got to kind of touch it every second or something. Just keep touching it to keep it alive, awake. So hopefully I didn't confuse you guys. And those two terms, you're going to see questions about those. Harvey, does it Make sense? Timestamp and agent time. You guys get it?
Yeah.
Or no?
It's pretty simple.
Pretty simple. The best things in life are simple, right? Okay, let's go on. So I think I showed this to one of my other classes. So let's say, Michael, on the job, your boss says, okay, it's time to update all this crappy switches we have here, right? Finally, we got money from head office, right? So we're going to go get some switches. And your boss says, all right, so here are the specs of what you're looking for in those switches, right? Here are the specs. Now, a few things, maybe not everything, but a few things here might be recognizable to you. For example, what is 48 here? 48 here refers to what? How many ports?
Yep.
Exactly. Because you have, I think 48 is the most you're going to get. You have 48, 24, you have 12, you have 6. So 48 is, so your boss just says, hey, I printed this stuff off the internet, so go to Best Buy, or actually Best Buy don't sell switches. Go to Micro Center or go online or somewhere and look for those specs. So okay, well, I'm looking for a switch with 48 ports. Then I'm looking for a switch with 8,000, right? Just like Cindy said, 8,000 MAC address. You can process 8K MAC addresses.
Mm-hmm.
Well, you can see a few things here. Flow control, which we talked about, full duplex, right? Those are all part of. Now, some of the other things here you may not recognize, like store and forward architecture, things like port mirroring. So let's see, like this store and forward. It's an important concept with switches. All right. The other things here, this is the IEEE, with their different standards, right? So let's see what the store and forward is. Let's go on here. All right. So you have these protocols, and this is now going to page, where is that? Page 379, I believe. No, page 378. All right. So 378, at the bottom of the page, you see kind of like a summary. So this is like features that you might find, on a switch. It's like specs, just like we saw here with this, let's say this printout from your boss, right? So you have the specs there. So you have cut-through switching. Now, just going by the description, just pretty straightforward. The cut-through switching feature means that when your data comes through, right, all the switch does is it looks at the source and destination MAC address. If that switch has some kind of errors for some reason or the other, well, the switch doesn't bother with the errors. As long as it has the correct MAC address, source and destination, it just sends it through. Okay? Now, I'm going to use a little bit of a gruesome explanation for this. Maybe not too gruesome, if you guys watch movies. Anyone ever saw this movie?
No.
I don't think so.
Anyone saw the movie or heard about the movie? Or read about it? No? What do you guys do for fun?
I haven't.
Just read and read and read? Okay. Well, so the Unimobile story, right? It's a real story. It happened a long time ago.
I know the guy, but I haven't seen the movie.
What do you mean you know the guy?
story,
Like
but
you
I
know
haven't-
him?
No, I don't personally know the psycho.
Okay, it's like you know him.
It's the reason we take our shoes off at the airport, right?
Yeah.
Exactly.
Yeah.
So this guy,
the guy who's the movie's about. Yes.
Okay. So this guy had a certain beef, right? He had a beef with college professors, right? He had a beef with college professors, and so he decided he was going to take them out. He had a beef with college professors and law enforcement. So he decided it was going to cause some serious trouble. So this guy moved into the woods, right? I mean, like he literally went off the grid, moved into the woods, and he will prepare all these bombs, like actual bombs, and these bombs, rig them with all kinds of explosives and very destructive pieces of equipment, right? And he set up his bomb. So basically, what he would do is he would, make his own bomb, and then he would package. All right, so this guy will, prepare his bomb, and he would simply, do this, right? He will take his bomb to the post office, right, and give it to them, and the post office will take the box or the package, and let's say it was addressed to this professor at 110 Main Street, wherever, right? They will deliver it to the professor, and once the professor opens up the package, boom, explosion, destruction of life and property. So here's the question that I have. Harvey, back to you. Why would, and this went on for a long time. He just used the mail service, and they would deliver the goods, and people were dying all over the place. So the question I have is, why would the post office deliver the bombs?
Well, at the time, they didn't really investigate the contents of the box, or really the what's inside. They didn't really have a system, I think, to really investigate it. And of course, it's their service, to deliver those packages. And I think from experience of mailing stuff from my end, like the post office only asks a few questions about what's inside. And honestly, I think you could lie even, or maybe that's just at Staples. But at Staples, they just ask you a few questions. You can literally lie, like I'm the one delivering the packages, or like handling the orders for the packages, and the customers just tell me, oh, I'm delivering T-shirts, or I'm delivering a box of, I don't know, something. But they could literally lie.
Yeah.
You never know, until you open the box, or if you have a system, some kind of security measure to scan that package.
All right, so that's excellent. And now maybe that will help you understand this cut-through switching, right? Maybe that's too much of an analogy, but maybe it makes sense. So the switch only, just like the post office in those days, right? They only look at the address. Like, okay, is it a valid address? We don't care what's inside. I mean, now it's different, but we don't care what's inside. As long as it has a valid address, boom, send it along. So we can see how dangerous that is. So with this first feature on the switch, all it looks for is the address on the message. Once you have the correct physical or MAC address, source and destination, it says no error checking. So that was what the Unabomber did for a long time until he was caught. Okay, so, well, when you think about cut-through switching, so if you see a question in your assignment, the Unabomber story is about what feature of the switch, right? Actually, that question is not on the assignment, but I might change my mind. Anyway, now the next feature there is store and forward switching. The switch reads the entire frame before forwarding it, right? It reads the entire frame, and here it says it makes sure there is no errors before forwarding the frame. Cindy, this should be familiar to you, right? I think we went through this in the other class.
Probably.
Oh man, Cindy, don't disappoint me here. This should be like, oh yeah, we've covered all this before. All right. So, all right. So the store and forward switching, that feature, right? It says it makes sure that there's no errors. So going back to the post office thing, let's say you scan the box to verify its contents, right? Are not in any way, going to cause any trouble, or it's not some kind of contraband or illegal items in there. And then the last option, the last feature that is available is it says if the switch reads enough of the frame to guarantee that it's at least the minimum size. So all that feature looks for is the size of the data, the size, right? Just the size. So if we were to summarize it, you're going to say the cut through is the fastest, right? But all the errors are forwarded. Fragment free. It only looks for like the size. It still goes through with the errors. But the last option there, store and forward, says no error frames are forwarded. So back to you, Michael. Your boss says, go get us a switch, right? And it gives you this sheet of specifications here. Mm-hmm. And now when you see the store and forward, is that something you recognize, right?
Yeah.
Because that's the feature you're looking for. You want to be sure that before the data goes through, right, the errors are checked. Just like it's a priority for the post office to know that whatever packages are being processed, right, are not, don't contain stuff that can, cause any kind of destruction to people's lives. Just like when you go to the airport, you got to be processed to be sure that, you're clean getting to the plane. All right, so keep an eye on those three features there. When you work in IT, these are things that, depending on your job, you might need to be aware of, right? Especially when you look at a specification sheet. You're looking at the specs of a device. You got to be able to, as much as possible, know the specs. Somebody calls you up, Cindy, and says, Cindy, I hear you're in IT. Okay, I want to buy a computer. What should I get? I'm seeing all this RAM stuff and GB. What's all that stuff? I need to get a good computer. Well, you should be able to, as an IT person, read the specs and say, okay, well, even if I don't know what it is, let me go and check out for you. Give me a minute. I'll be back to you to look at the specs for the device you're trying to get, right? So for a switch or for a regular computer, that's going to be your job one day, to do that on a full-time basis. All right, we got a couple more things here we should look at on page 379. Some advanced features of switches. Let's see a few of them here. Multicast processing, spanning tree protocol, virtual local, area networks, port security. Let's see what that is. So spanning tree protocol. So this is about, how do I say now? Think about it as a loop, right? If you have done any kind of programming, right, you might have come across the idea of loops. Maybe what we call for loops, while loops, something like that. Loops that allow a program to run endlessly until something stops the loop from running. Okay. So with a switch, when multiple switches are daisy chained, right? That's what happens, typically when you set up switches. Just like in this picture you have here, you're going to have multiple switches all connected together, right? To create right here, multiple switches. So you're going to have multiple switches, in a very big office. So all these switches, we can say they are daisy chained. Each one is connected, not just the computers and the cables, the actual switch devices themselves. They all have to be connected together. That's what makes your network function the way it is. all the switch devices are not isolated from each other. They are all connected, right? Okay, so when that happens, there is a possibility that data that is meant for one of the switches just keeps going back and forth, back and forth. It goes from the top switch to the bottom switch to the next one back here. Just kind of like just keep going endlessly looking for a destination. Just can't seem to find a destination, right? I mean, it's like if you, let's say, think about it as, you know, you're going to, well, you're going to some place, right? You're going to your aunt's house or somebody's house, and you get lost, which happens every once in a while, right? Even with your GPS, sometimes you still get lost. Like, where is this address? I can't seem to find. The GPS tells you you have now arrived, but you're like, I don't see the house. This actually happened to me just last night. I mean, I was literally right there, but the address didn't exist, which was kind of crazy. Anyway, so you're kind of lost. And so you just keep going around and just going in circles, right? Now, that happens to switches, right? Switches, sometimes the messages just go in circles. It never gets to a particular place for some reason, right? That is called, right here it says a switching loop. That's what it's called. There's a switching loop that's now occurred, a switching loop. So how do we solve that? Now, if the switch has this STP feature, right, the spanning tree protocol, it says when a loop is detected, one of the switch ports goes into blocking mode, preventing it from forwarding frames that would create a loop, right? Very important. If a switch detects that there's a loop, a switching loop going on, the message never seems to get to where it's supposed to get to. It just keeps going back and forth. The switch, this advanced feature on the switch goes into action, what we call blocking mode, and it prevents that kind of stuff from happening. That's basically what it's saying. And then at the bottom, it says, if the loop configuration is broken, the switch that was in blocking mode resumes forwarding frames. So it's kind of like, you know, the switch just blocks everything from happening, ends that process, and then resumes its regular operation. That's how the switch is set up, right? So when you look at the book, right there on, what page are we on now? We are on page 380. So you see the examples there, just like this diagram. So you have all the switches, switch A, B, C, and D. The message just goes back and forth in the loop. So a switch that has the spanning tree protocol feature can prevent all that stuff from happening, right? So a couple of times, you know, maybe once in a while, a message maybe never gets delivered because of this loop. So we have to block that stuff from happening and then continue with our regular process, right? It's like sometimes maybe the post office is trying to deliver mail and somehow, you know, it just never gets there. Or maybe you moved your address, you never notified the office, or you never notified the post office, and so it keeps going back to your old place. It never gets to you somehow. You know, things happen. But this is a possibility with switches, right? Now, like I've always said, some of this stuff may not be relevant to you, even when you start your job. Some of it may be, but there are things for you to kind of like put in your notes because, you know, IT, in as much as we have technological change, some things still remain the same. So you need to be aware of all this background information. Just keep them somewhere in your notes and file it somewhere on your bookshelf. One day you might need that information. It happened. I always go back to very, very old notes, all right? Because all these things keep coming back. So you might even have an interview with an ultra sharp interviewer who pops up a couple of questions to you. And you're like, what's flooding the frame again? And then you're like, what? Well, you got to know what that stuff is, right? This is all part of intro to networking. All right, let's move on. So we have all the protocols there that you might want to take a look at. I'm just going to move on. Switchboard security. This is an important one for security reasons. It says right here, just the description is good enough for us here. In some public buildings, network jacks, that is, the network jacks on the wall jacks. So that's your wall jack. You see them. What am I doing here? Well, that's a picture of a network jack. So that's it right there. You have it, on your wall. You have it, in the office, at home. Network jacks. You can just plug your cable directly into it. Okay, that's what it means. So in some public buildings, network jacks with connections to switches are often available to public users. So you can go to a library or go to the campus, right? Campus center or something. You can easily plug a laptop, into those network jacks directly with a cable. And it says in this situation, it can be a virus attack or it can be a hacking tool or some other malware, right? So a switch that has the switchboard security feature in that switch, right, is able to prevent, this kind of, unauthorized activity from happening, right? The switchboard security is the feature that will prevent, an unknown device from being able to penetrate a network. Okay? It says it also enables an administrator to limit how many and which MAC addresses can connect to a port. So if you work in a company, your IT guys are going to basically register your device, especially your MAC address, as a known and authorized device that can function in that network. And block, and basically, it's like, I think it's the concept of, it's called access control list, but also the idea of whitelist and blacklist, right? Where these addresses here are allowed into the network and these addresses here are not allowed into the network. So your device as a valid device will be registered so that when we see activity of devices that are not registered, then we can identify them and, do something about it. So that's what it says at the bottom here. If an unauthorized computer attempts to connect, the port can be disabled, and then the administrator gets a message of the intrusion, right? So switching devices, all these devices we looked at here, are not just, you might never have really known what these guys do, but obviously you can see they do a lot of stuff. They're configured as very smart devices that help to direct and protect data that's going back and forth from your system. Okay, let's move on here. So that's switches, right? Does anyone have any questions so far about switches? We're going to go to routers and look at what we have about routers. Justin? Were you clear on some of these things we talked about? Where's Justin? Jojo?
Yes, I'm here.
Did this make sense to you, some of these things we talked about? Or did I leave you in a heap of confusion? What?
It's all coming together.
It's coming together, right? All right. All right. Let's take a kind of like a quick look at routers for how much time we have left. Like I said, a lot of these things, some of it is just things we've talked about before. A few things might be new to you guys. So routers operate on layer 3, and Jared, layer 3 is what's on layer 3 again? Well, it's right there, right? So that's an easy question. Jared. Where are these guys when I call people? Justin, Jared, no response. Edwin, you there?
Yeah, I'm here.
Is everyone taking a bathroom break? So layer 3, right? That's your network layer, right?
Yeah.
And that's where routers operate. So Edwin, what's the information that routers look for on layer 3?
MAC address.
Did you say that? Did you say what?
Was it MAC addresses? I don't know.
On the network layer, Edwin? Come on. Did we spend the whole of chapter 7 on this? Layer 3, the network layer. Amy, what's that? Amy, where you at?
I'm here. Sorry, I was on mute.
Yep.
Routers work with the data between networks.
So what's the data?
Packets.
So it's called a packet. You're correct. What's the information in the packet that we're looking for? At least one of the critical information pieces is what? Come on, Amy. What's it called? Where's Amy?
I'm here.
What is that information? It's a packet. Yes, you got that right. What's the information in the packet?
Broadcast frames.
What is broadcast range? There's an address we're looking for, Amy. What's the address? We just talked about switches.
address.
Switches have frames. Frames are MAC addresses.
Yeah.
What of routers? A network layer. That's what?
IP addresses?
Is that a question, Amy?
No,
So are you sure it's IP addresses?
not 100%.
All right, who's 100% sure? Brooke, are you 100% sure or not? Because for me, I'm thinking that this is just like old stuff. So obviously some of your classmates are not getting this. So Brooke, what's the information we're looking for on layer 3?
I'm not sure either.
This is a bit surprising, I must say, but maybe not surprising. I don't know. Anthony,
Yes.
what is it?
Isn't it IP addresses?
Was that a question?
No.
So the original question was so the packet she was talking about, so it has the MAC address, and like since it's a frame basically, so and then the frame has the MAC address of the person, the client. Yes.
The question I
That was
asked
the
is,
answer
what
that
is the
you were looking for, right?
information in the packet? What address are we looking for at the network layer, guys?
The IP address and the MAC address.
No, we're not looking for the MAC address. No, absolutely not. The network layer only deals with the IP address. When it goes from the network layer to the next layer, the data link, then it picks up the MAC address. So the packet becomes a frame, not the other way around, Abdurrahman.
Oh, sorry.
The packet becomes a frame, not the frame becomes a packet.
Yeah, I got confused. Sorry.
So the packet, right, when it gets to the network layer, it grabs the IP address. It's a packet. It moves on to the next data link layer. It grabs the MAC address, then it becomes a frame.
So the IP address.
So layer 3, network layer only deals with the IP address. Layer 3, right?
Yeah, you're right.
So right here, if we go back to when we started switches, all the way right here. Switches work on the data link layer, layer 2. That's where you deal with MAC addresses, no?
Sorry, are you asking me the question or?
Well, it's just kind of rhetorical.
I mean, they do deal with
Finish your sentence. They do deal with what?
No, I was just saying. So like I was saying, you were correct. So like, so the way you were explaining it was like the front, not frontward, but the backwards. Like you said it in a way that like you started from like data frame. So like when you said frame, I just automatically thought like the way you were explaining it, like because like the way I've memorized it was that like the first IP address is grabbed, and then when it gets down to the network layer, and like when the frame's grabbed, the MAC address is then grabbed.
Okay, so the question for you is, at what layer is the IP address grabbed?
So it's the it is the I just remember. Oh my god.
Anybody want to help out, Abdurrahman here? What layer is the IP address grabbed?
On the third layer, in the network layer.
Okay. So, the way it's because the OSI model is a bit confusing in how it's laid out. So when we say on the third layer, right? Remember, it goes from 7, 6, 5, 4, 3, 2, 1. Abdurrahman.
Oh, okay.
Are you with me, Abdurrahman?
Yeah, I'm with you. I'm looking at it.
So it goes from 7, application, 6, presentation, 5, session, 4, transport, 3, network. Network is when it gets the IP address. Then it goes to the layer 2, which is your data link, and it picks up the MAC address and becomes a frame. So it's a packet first before it becomes a frame.
Oh, I'm with you. Now I understand.
Okay. So it has to get the IP address first on layer 3, network layer, and then it goes and gets the MAC address on layer 2.
And then becomes frame.
Exactly.
Okay, now I understand.
If you remember, I talked about how crazy the OSI model was set up. How the numbers are 1 to 7, but it's kind of like backwards in how it was set up,
Yeah.
So that's why I said you guys don't be confused with that, because you might think logically in your mind it goes from 1, 2, 3, 4, 5, 6, 7. No, it goes from 7, 6, 5, 4, 3, 2, 1.
Yeah, I was thinking it goes from 1, 2, 3. Yeah. Now I just.
Okay. Let me just pull this picture, and then we're just going to run it up there. So OSI model. Obviously, you guys need this little bit here. So let me just pull this up again.
I think about it in terms of like how a stack works in programming.
So hang on. So here's the OSI model, right? It goes from application. Now, unfortunately, let me say the way it is designed, the application is layer 7, right? 7 presentation. Okay, let me see if I find one with numbers. Do I have any with numbers here? Right here. That's not a good one. Yep, here's one with numbers. All right, so here's one with numbers, right? Abdurrahman, are you still with me?
I'm with you.
So it goes from application. Now, you would think that maybe physical should be number 7, right? Like, okay, you're going, but this is how it's numbered. So you start from application from 7, you go to 6, you go to 5, you go to 4. When you get to 3, right here, it picks up the IP address and becomes a packet. You see that?
Yeah, I'm with you. Yeah.
Then it goes down to layer 2 and picks up the MAC address and becomes a frame.
It's vice versa. Okay.
Whoever wrote this here, I'm sure failed this assignment because right there, here talking about packets. Right at this point, it's a frame. Right? So remember that. You know, I know the numbering is confusing because when we say, you would think that
numbering.
Go ahead.
I thought the network was before the data was before the network. Because like I was counting it from physical, like physical being the top.
No, physical is at the bottom because physical is your cable. Yeah,
now
it's your cable. That's the last. Okay, that's the last part of your whole process, right?
Yeah,
when the data is going out of your network.
Yeah, now it's like I know it's like a hill where like application and then presentation, session, and transport, network, and data link and physical now. Because I was doing the whole opposite way, but now I'm very clear. Like it's very clear.
Okay, well, if that was helpful, so let's wrap it up there, and we'll pick it up, finish it up on Thursday, chapter 8. All right. All right. Let's do the attendance.